Here we are going to see methods to express the concentration of a solution, the two methods that are molarity and molality. So in the previous part we have seen that we can express concentration of a solution in different ways, and in this chapter we are going to see mainly three. We have already seen in the last part, that is mole fraction. In this part we are going to see about molarity and molality. So first what we are going to see is molarity, denoted by small letter c. In certain books you will see that molarity can be also expressed as capital M or denoted as capital M, not expressed, denoted in capital M. So many books you will see molarity denoted as C, and in many books you will see it is denoted as capital M. Both are right, but if you are decided to stick on with a notation, you should stick with it. You should not interchange between the symbols. So here I am using small letter C. You can also use capital M. Molarity is denoted by capital C. So whenever you see a C in my slides, it stands for molarity in the equations. Okay. So what is molarity? Molarity is the number of moles of solute dissolved in 1 liter of solution. So we have a solution, and in the solution we have, what are the two components that we will have? We have solvent and solute. So if you're taking 1 liter of solution, just how much number of moles of solute is present in that? That's what we call it as molarity. Again, number of moles of solute present in or dissolved in 1 liter of solution. Not solvent, make it sure it is solution. So you dissolve solute in a solvent, and after that you will get the solution. In that solution, if you take 1 liter of solution, how much moles of solute is dissolved in it? That's called molarity of that solution. Clear? So it is the number of moles of solute dissolved in 1 liter of solution. So let's try to find it out using a max. If 5 liter of a solution, so they have provided the volume of solution. So here it is what is molarity? Number of moles of solute dissolved in a volume. That what is that volume? 1 liter of solution. Here they say that in this problem they say that if 5 liter of a solution has 10 mole of solute, so the volume is 5 liter. And how much solute does it have? This 5 liter has is 10 mole. And what is asked is, what is the concentration of solution in molarity? So we know the definition of molarity. What is molarity? Molarity is number of moles of solute in how much solution? In 1 liter of solution. But what they have provided is the entire volume of solution, that is 5 liter, and the number of moles of solute in it. So what I have to do, I have to find out how many moles of solute is present in 1 liter. So if in 5 liter if it is 10 mole, then in 1 liter how much will be the number of moles of solute? So we will see how to calculate this. Number of moles of solute in 5 liter of solution is equal to 10 mole. So number of moles of solute in 5 liter of solution is equal to 10 mole. So in order to get that number of moles in 1 liter, what we have to do is, so number of moles of solute in 1 liter solution is equal to total number of moles in the solution divided by the total volume of the solution, that is 5 liters. Then you will get number of moles in 1 liter, 2 mole per liter. That is called molarity. So what is the molarity of this solution? Molarity of this solution is 2 mole per liter. It has a liter of this solution has 2 moles. That's what we call it as molarity. So how to get molarity? What will be the equation that can be used for molarity? You can see here. It is number of moles of solute. This is number of moles of solute in the solution, right? Divided by volume of the solution in liters. This is volume of the solution. Volume of the solution in liters. So let's make that formula now. Molarity C is equal to number of moles of solute in solution. Number of moles of solute in solution, that's what we have done, 10 mole, divided by volume of solution in liters. That's what I have done here. So if you do this, you will get number of moles in 1 liter. If you are doing this max here, you will get number of moles per liter. Clear? So if you are using notations, like I am using molarity C for molarity, number of moles of solute means N subscript B, and volume of solution means Vs. We will see that. So C is equal to En subscript B means this is number of moles of solute in the solution divided by volume represented by capital V of solution, and that must be in liters because the definition is in 1 liter of solution. So I have to use the volume in liters, volume of the solution in liters. So again C is equal to number of moles of solute divided by volume of solution in liters. Clear? Sometimes they will not provide number of moles. Instead, they will give mass of the solute. So here instead of 10 moles, if they are giving mass of the solute, I must convert that into moles. How can I do it? If they are providing mass, I must convert that into number of moles. So instead of NB, I must apply this equation. C is equal to mass divided by molar mass. What is that? That is number of moles. So mass divided by molar mass into. So instead of NB, I can also use this formula. So if they have, if the question is asking in mass, and if you know the molar mass, you can apply this equation. If the question is in number of moles directly, then you can use this equation for molarity. Now, what is the unit of molarity? From the definition itself, it is clear. Number of moles. So moles in 1 liter per liter. That's the unit. So unit of molarity is mole per liter. Or you can simply, instead of writing mole per liter, you can simply write capital M. So this is universal. You have to use the unit capital M or mole per liter specifically to express the unit of molarity. You can use either capital M or C for notating or denoting molarity, but as a unit when you should always use either capital M or mole per liter for molarity. Let's see a problem based on molarity. Calculate the molarity of a 250 ml solution. So they have provided with the volume 250 ml of the solution that is prepared by dissolving 4 gram of NaOH. So they have given the mass of solute, that is 4 gram of NaOH. So calculate the molarity of a 250 ml solution that is prepared by dissolving 4 gram of NaOH. So what's our equation? Our equation is molarity is equal to number of moles of solute divided by volume of solution in liters. Since they have not given the number of moles here, we can use the second equation, that is number of moles can be also written as mass divided by molar mass. So what is the mass of NaOH given? That is 4 grams. 4 grams divided by molar mass of NaOH. If you calculate molar mass, it is Na, for Na it is 23, for oxygen it is 16, and for H it is 1. So 23 plus 16 plus 1 is equal to 40. So we will see all these values. Volume is given in 250 ml. So I need to convert it into liters if I want to use for molarity calculation, because it is volume of solution in liters. So volume of solution liters is equal to 250 divided by 1000, that is equal to 0.25 liters. Clear? So how to convert ml into 1000? Ml must be divided by 1000, so that will be converted into liters. Now what is the molar mass? That is equal to 40. So you just add all those atomic masses of these atoms present in the compound. So we have 40 gram per mole. And we have Wb, that is 4 gram. You substitute all these values into this equation to get the molarity. So C is equal to Wb by Mb by V is equal to 4 divided by 40 divided by 0.25 liters, and the answer is 0.4 mole per liter. So don't forget to express the unit. You can either express as mole per liter or you can express as capital M, 0.4 molar. Clear? So this means molar. This is mole per liter. Molarity in short form you can write molar, M-O-L-A-R, molar. Clear? So you can write it like this, or this means capital M. This means that it is 0.5, 0.4 molar. This is how it is read. You're not supposed to write like this. You're supposed to write capital M, but it is read like this, 0.4 molar. Okay. Next problem. Calculate the mass of sodium acetate. So you have to calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution, and molar mass of sodium acetate is given. So what you have to do is you have to calculate the mass of solute that is required to prepare a solution. How much is the volume? 500 ml. And how much molarity is required? 0.375 molar. Means that's the molarity that is required. So in the previous problem we saw the molarity, or we calculated the molarity. In this problem they are asking to find out the mass of sodium acetate. Clear? So let's see the formula. We have the formula like this. So C is equal to Nb divided by its in number of moles. What they have asked is for mass, and what they have provided is also molar mass. So we have to use the second equation. Second equation is Wb divided by Mb into V. So what are the variables that we have here in this question? We have C. C is given 0.375 molar. And what is given? Volume is given 500 ml, but here what we need is in liters. So when I divide it by 1000, I will get 0.5 liters. And also they have provided EMB, that is 82.0245 gram per mole. So all the variables is provided other than mass. So you can calculate the mass from this. So WB is equal to, so you rearrange it, C into MB is by going to this side. It's like this, MB into volume. You just simply substitute the values. WB is equal to 0. Its molarity, its molar mass, its volume, and you will get the answer as 15.38 grams. So if you want to get 0.375 molar solution, how much liters? 0.5 liters or 500 ml solution of this molarity, you have to do is you have to take 15.38 gram of sodium acetate and dissolve to make the solution of 500 ml. Clear? So this is about molarity here. So next we have 30 ml of 0.5 molar H2SO4. So 0.5 molar is the concentration of H2SO4 solution, and the volume of the solution is 30 ml. It is diluted to 500 ml. So that means diluted means you are adding water. So you will add water from 350 ml. You will add water and make the solution volume to 500 ml. So how much water you have to add? You have to add 470 ml of water. Initially it was 30 ml and the concentration is 0.5 molar. Now you add 470 ml and you have the new solution whose volume is 500 ml. Now I need to calculate the molarity of the new solution. So molarity, what's the molarity of, so I will give this molarity C1, initial molarity, that is 0.5 molar, and its volume I will give it as V1, that is 0.03 liters, because molarity calculation, it is always convenient to convert ml into liter, 0.03 liters. And what is the second volume? Second volume, that is V2, is 500 ml, which will be 0.5 in terms of liters. So 0.5 liters. Now what is C2 is what we have to calculate. So molarity equation is, so one thing what you have to remember is that the number of moles is not changing. In both the case we have, if it is 30 ml or even if it is 500 ml, we are not adding anything new. In the case of H2SO4, we are only adding water. We are not changing the number of moles of H2SO4. So that means the solute concentration, which is the solute number of moles NB, remains the same. Okay, so that's one thing that we have to notice here. What's the formula for molarity? In the case of first molarity, C1 is equal to number of moles of solute divided by the first volume, that is 0.03 liters. And if you can rearrange it, you can say that NB is equal to C1 into V1. Now the second case, C2 is equal to, again the number of moles is not changing, so it's NB by V2. So you can say NB is equal to C2 V2. Clear? Now if both these sides are the same, NB is the same here and it's the same NB in the second equation, so left hand side is the same. So you can say that if this is the same, if this side is same, then we can equate between right hand side, isn't it? So C1 V1 is equal to C2 V2. Clear? So in this we know three variables. In this equation we know three variables, so the unknown C2 can be easily calculated. C2 is equal to C1 V1 by V2, substituting the values. C1 0.5, from here 0.035 for V1 divided by 0.5 for V2, you will get 0.5 and 0.5 will cancel out, so we will get 0.03 molar, or mole per liter is the molarity of new solution. So by diluting, you can clearly see that the concentration has gone down from 0.5 to 0.03 molar. So what you have to note is this important equation. If the number of moles is not changing in a solution, and if you are diluting, you can use this equation to find out new molarity or volume, whatever it is, whatever they are asking. If the number of moles is not changing, you are not changing the solute moles, then you can use this equation, C1 V1 is equal to C2 V2. And in some textbooks, as I said, they might use M here instead of C, so you will see there as M1 V1 is equal to M2 V2. So that's about this problem. Next is molality. So this is the second way of expressing a concentration that we are seeing in this part, and it is denoted by the small letter M. So first one was molarity and this is molality. How to define molality? Molality is the number of moles of solute dissolved in 1 kilogram of solvent. So this is about solvent, not solution. Here solvent is expressed in as a mass. So in molarity, it was the volume of solution. So volume of the solution, the problem is that it varies with temperature. Whereas in the case of molality, it is a mass of solvent. Mass never varies, it's a constant. So that's the advantage of molality over molarity. Again, molarity, molarity, R-I-T-Y, molarity means number of moles of solute dissolved in 1 liter of solution. So that's a volume. Whereas in the case of molality, here the solute is dissolved in 1 kilogram of solvent. So 1 kilogram means it's a mass, and mass is a constant. Whereas if you are taking molarity, where we have 1 liter, that means volume of solution might change when temperature changes. So as we know that when we move across the countries, temperature changes and the volume also changes slightly. So there will be slight variations in the expression of concentration. What is universal or universal way of measuring the concentration will be, then appropriate way will be molality. So what is molality? Number of moles of solute dissolved in 1 kilogram of solvent. Number of moles means it's a mass. Mass divided by molar mass dissolved in 1 kilogram of solvent. Again, this is solvent, it is not solution. Let's again take the same max that we took for molarity. If 10 mole of a solute is dissolved in 5 kilogram of solvent. So what is molality? Number of moles of solute dissolved in 1 kilogram. We have here 10 moles of solute is dissolved in 5 kilogram of solvent. So what is the concentration of solution in molality? So we have in 5 kilogram solvent, we have 10 moles. Dissolved is 10 moles. So how to get in 1 kilogram? You just divide it by 5. So what you will get is 2 mole per kilogram of solvent. So in earlier one, in molarity, it was 2 mole per liter of solution, whereas this is 2 mole per kilogram of solvent. Clear? So from this, we have number of moles divided by mass of solvent in kilogram. So let's see based on this how to make a equation for molarity. Molarity, as I said, denoted by small m, is equal to number of moles of solute in solution divided by mass of solvent in kilogram. So what you need is moles of solute, as we know, as we have with the molarity, we have the same numerator here, but in denominator we have mass of solvent in kilogram. As you can see here, is number of moles of solute in a solution, and we have what we have is mass of solvent in kilogram. Clear? So if you're using, instead of if you are using notations for all this, how can we use it? Molarity is equal to number of moles of solute divided by mass of solvent, denoted by WA, A in kilogram. WA means solvent, A means solvent, so WA in kilogram. So if it is given, it's not, if the solute concentration or solute number of moles is not given as number of moles, if it is given as a mass, so you can use this formula, the second formula, that is molarity is equal to WB by MB. So mass divided by molar mass of the solute into mass of the solvent in kilogram. Clear? So this is how you can use molality equation. Very much similar, only thing is that in the denominator, instead of solution, we have solvent for molality, and that too in kilogram. So let's see a problem based on this. Again, the unit of molality, I'm sorry, here it is L, not R, so it is molality in is mole per kilogram, or small letter m. Let's see a problem based on this. So again, unit of molality is equal to mole kilogram raised to -1, or small m. A solution is prepared by adding 2 gram of substance A to 180 gram of water. So we have a solute whose mass is 2 gram and it is added to water which is solvent, that is 180 grams. Calculate molality of the solution. Molar mass of the substance A is given, that is 40 gram per mole. So we have the formula, that is M is equal to WB divided by molar mass of solute into mass of solvent, that is 180 gram of water, but it is in kilogram. Here it is gram, but we have to do this in kilogram. So let's see, WB is 2 grams. It's prepared by adding 2 grams of substance of A. So WB is 2 gram. Molar mass is given, that is 40 gram per mole, and WA is 180. According to the equation, we have to make it into kilogram. So it is equal to 0.18 kilogram. So how to do it? Divided it by 1000. So you will get that expression in kilogram, that is 0.18 kilogram. You have all the values. You just substitute them into the equation. You will get 2, that is WB. MB is 40 into 0.18, which is equal to 0.28 mole per kilogram. Or you can write simply as small letter m. So either its unit of molality can be either expressed as mole per kilogram or mole kilogram raised to -1, or you can express this simply as small letter m. So for molarity it was capital M, and for it is small letter m. And how will you read it? Read it like this: 0.28 molal. So I will write it down to make it more clear. It is M means molal. Clear? So earlier when it was molar, then it was capital M. Now it is molal, means 0. It means small letter m. Okay, so that's the difference. Okay, I hope you enjoyed the class. Study well.